Hi everyone, my name is Arezou. Thanks for coming to my presentation. I work as Senior Machine Learning Engineer at Atlassian, and today I'm going to talk about LLMOps, and by that I mean productionizing large language model. Also discuss some of the differences between LLMOps and MLOps. This picture is one of my favorite MLOps images. There's this guy whose name I think is Mio. He tries to bring ML concepts to life. I really like this drawing because it's nicely represent how much hassle it takes to put a model in production. You know, when we have a problem and we want to use ML to resolve that problem, we most of the time thinking, building a model itself is the final step, but there's so much processes and techniques that you need to apply to put that model in production. And I kind of think this kind of rocket shipping analogy nicely represents that complexity. So let's make sure we all have common understanding about the technical jargon that I'm using today. Nowadays, people use MLOps to talk about traditional and statistical AI as opposed to foundational model or generative AI, where we use LLMs. With MLOps, in general, the spotlight has been shifted from algorithm design, model training, and hyperparameter tuning to basically shipping the model. So we want to have a reproducible and adaptable process to put a model in production. So basically, the definition that we can provide is MLOps is a production process for serving, monitoring, and improving a model. Also wanted to emphasize the improvement part because that's an important part of MLOps that you also need to take into account. So your model basically, when you train it, is a snapshot of the world when you collected the data and you train your model. And just like human, when things change around you, you need to adapt. So we want to make sure we have an automated process in place so that we can improve that model in the long term. Moving on to LLMOps, as I said, usually we use these terms, a new term we use to talk about productionalizing generative AI. So with the generative AI, there are this category of like text generation, where we usually use LLM, and also image generation, where we use diffusion model. I'm not going to cover diffusion model in this topic. It's just about the text generation. So it does have a lot of commonality with the MLOps, but it also has some additional challenges that I'm going to talk about. Okay. So before I discuss the challenges of LLMOps, I wanted to quickly deep dive into a real-world use case when a product is crafted with and without LLM. And that product, obviously, is from Atlassian. It's called Virtual Assistants for JSM. We call it Atlassian Assist. Does anyone know what is the difference between JSM and Jira? No one? Yeah, that was my first question when I joined Atlassian. So Jira is basically Atlassian flagship product. We use it for project management and issue tracking, all those, Kanban and Agile board that we have. Whereas JSM is kind of like tuned for IT service management. It does have several features that Jira doesn't have, like for instance, customer-facing portal. So let's assume, if you are a service provider that usually have customer that needs troubleshooting, things like that, need to talk to human, we can use JSM. So with the Atlassian Assist, we do have 2 tiers of support. Tier 1 is basically our in-house supervised model that we train based on your data that you provide, and tier 2, which is basically integration with ChatGPT. So with the tier 1, there are 2 important concepts. One is intent, and the other one is intent for. So with the intent, you can think of it as your customer most frequently question. It's like a cluster of questions that you get from your customer, and then you label it as an intent, right? And then with the intent flow, you basically want to dictate what happened when a customer asks you a question. Just to give you a, show you how the product experience is different between tier 1 and tier 2. This is tier 1, when you can see we can define the different intent. Like for instance, in this project, I have defined different intent for Tableau, Zoom, VPN troubleshooting, whatever your business requirement is. And this is an example of training phrases for your particular intent, right? So this is basically a supervised machine learning where you provide labeled data, and based on the data that you provide, we train a model for you. So with the intent flow, the second step that you need to configure is basically what you want to happen when a customer asks a question. For instance, in this example, let's say a customer has a, I don't think the font is readable, but when a customer, for instance, has a Zoom issue, I configure this intent flow to say what I want to happen. So with this example, I say confirm whether this is related to Zoom, and if the customer says yes, this is a Zoom issue, I want to drill down and see what is the exact problem. I want to ask, do you have a problem with accessing Zoom, permission issue, or integration with different products, and so on. And you can see this is the end user experience. So I ask a question. Obviously, we have trained a model that can recognize Zoom question. And then this option that you can see is based on the configuration that comes from the intent flow that I just mentioned. So tier 2 is obviously the ChatGPT integration. Last year when GPT came out, a lot of people, businesses have been impacted. We were not excluded, so we also had to integrate it with our product. It does resolve a lot of manual configuration part, like the pain point that you had with building your own model. So you basically don't need to define any intent. You don't have to configure any intent flow. Instead, you just need to, there's a toggle. When you go to the virtual assistant, you just need to turn it on, and also you need to provide some knowledge base article, which in our case reside in Confluence. This is an example of how it looks like. So, for instance, I want to activate GPT-4 responses for my Help IT Slack channel. And as I said, you need to also link it with the basically your troubleshooting knowledge base that you want the model to respond with. So also I wanted to emphasize with this 2-tier support, this is not kind of like this or that option. From the back end, if a help seeker question can be resolved with a established intent, we go ahead and take it through the intent classifier, the model that we have trained based on your data. Otherwise, we call the ChatGPT and generate an answer based on the provided knowledge base, right? So if neither of those cases happen, we give the help seeker the opportunity to scale the question directly to a human. So a valid question here is that why we don't just anchor to a smart answer and get rid of the in-house model that we had in our product, which I'll explain later. All right, I guess with this intro now we have the context to deep dive into challenges of LLMOps and understand what has changed and what is going to remain with MLOps. So before ChatGPT era, when the topic of MLOps was brought up, there were these kind of like 3 main pillars that needed attention. The first one is model serving, basically the process of taking a model and putting it behind an API, often RESTful API, so that other software component can interact with your model and consume it. This is sort of like a classic simplified serverless architecture, hosting your model using AWS tooling. where you can basically wrap your SageMaker prediction with AWS Lambda and AWS API Gateway. The Lambda runs your private network, whereas the API Gateway interact with your public web client. The second one, obviously, we wanted to always reduce the inference latency. We want to have a service that has the minimal response time, specific to ML. We had these two kind of category of using hardware acceleration technique, like for instance, using GPU, or if you can afford using just hardware, there are also some non-hardware technique, like for instance, applying quantization technique, where you can basically simplify some of your calculation to reduce the inference latency. And the third one is the continuous training. So we always have with any system, continuous integration, continuous development, but specifically you need to ML system. We also want to make sure we had a process in place to continuously improve our model and get the feedback data and train our model. So moving on to LLM op, kind of the main idea of using LLM is that we have this big model that has a great common sense. So we don't want to train a new model. It's even very less likely that we fine-tune the model. So we don't want to be basically bothered with all the data collection and data labeling. And if you go one step back, how LLM works, basically what it does is that if you have based on the training data, if you have a series of tokens, it predicts what is the most probable token. And by that I mean, it doesn't rationalize, or it can reason about what is the next token. It's just based on the statistic that it has been observed in the training data, right? And the term stochastic parrot often comes up to imply to that kind of blind prediction. And because of that, if you want to use LLM for your application, you need to align LLM responses for your application so that it doesn't blindly parrot. So this one is from the survey of MLOps, the MLOps community that identifies some of the main use cases for LLM. You can see among the top, chatbot, information retrieval, text summarization, text generation are among the top. And when you look at all these different applications, you can technically categorize these generative AI use cases into three main buckets of retrieval, action, and computation. And depending on your category, you need to, as I said, make some intentional effort to make sure LLM responses respect your business logic. So with the retrieval use case, you basically let the LLM find relevant information to be more accurate in providing a response, such as live data sources that was not trained in the basically in the trained data. And a good example is like Bing search. So with the action, you basically let the LLM take some action on behalf of a human. For instance, when you say browse the internet, or I don't know, create a Jira ticket for me, things like that. And the third one is compute. You let the LLM to connect to other services to make some computation for you. We all have this experience, if you have used ChatGPT 3.5, it's not great at math. So for instance, you may want to let LLM to connect to Wolfram Wi-Fi to do the mathematical calculation for you. Okay, so basically there are three ways if you want to perform task alignment for your application. The first one is in-context learning. Basically what it means is that the model is unfrozen and all that learning happens at the inference time. Basically the context window that you have, that's all you basically use to give more directed instruction to LLM. And that is the number one approach for task alignment. The second one is fine-tuning. So model is unfrozen, and the weights are updated based on feedback data. This is really uncommon. I haven't seen any company do it, at least at the industry scale. The third one is training a small specialized model. So basically, the big generative AI gives you a powerful base to start with for your prediction, and then based on the data that you collect, you train a small model, kind of like branch off from the large language model. And the small model could be even like a traditional ML model artifact. It doesn't have to be an LLM. This one is kind of like the second most popular. To give you an example, again, what do I mean by in-context learning? So if I go to ChatGPT and ask, what is campus? How can I use campus? This is the response that I get. But in my case, I want to prioritize this response to the first one. So Atlassian is another, Campus is another Atlassian product when you can basically gather all the information about your service. So that's what I meant by in-context learning. So you want to basically change LLM response based on your business. Again, there are so many different ways you can implement in-context learning. We don't have time to fully cover that, but just to give you an idea, how does it look like? I have put a simple diagram where I assume your customer-facing interface is Slack. So starting off from here, the help seeker asks a question. You probably have a prompt in place before. And then step number 2 is that you get the query. You basically retrieve the relevant information from your knowledge base. We had a session about the vector search. If you have already attended, you know why we use vector search for LLM information retrieval. And then once you retrieve the relevant information, you feed it, you squeeze it as the context to the model. In this example, again, I'm assuming you are using a LangChain engine. And then once you've got the prompt, query, and context, you send it to the OpenAI, and you get the response back. So basically, context lens is a very special, important parameter, especially for retrieval use cases. A general rule of thumb is that the longer the context lens is, the more information or instruction you can squeeze into your context, and it's more likely that you have a better model. So that's one of the reasons why most of the commercial LLM has better performance compared to open source one. Exclude MPT for now. I'll get into that. So just getting back to the 3 pillars that I explained before. Now most of the conversation around model serving has been shifted to task alignment. Again, just getting back to the information retrieval use case, if you want to change LLM response, you need to do a lot of additional effort to set up your knowledge-based response and do a lot of embedding, pre-embedding, and vector setup, basically setting up your vector database. Inference latency, again, it depends on the GPT model selection. There's always a trade-off between model size and quality. Continuous training, there isn't really any answer to that just yet. What happens is that most of the time we collect feedback data and then we just go back and iterate on the prompt and try to optimize the prompt. And then there are more discussion now about the reliability, model observability, and cost estimation. So first one, reliability. So in the engineering work, when we used to have this kind of like written instruction using programming languages, and all the do and don't, we had to program it, whereas with the LLM, we are no longer confined to any programming languages. We can just use human language to tell the model what to do. And there is kind of like two directions into it. Basically, we use human language to define instruction, but on the other side, we need to see how much basically LLM follow this given instruction. There's basically a term for it that is called steerability, which basically means whether, like, to what extent LLM follow your instruction. And so far, GPT-4 has been the most steerable model. The other big part of the reliability is harmonization. As we all know, GPT can be confidently wrong, and that is the #1 roadblocker for a lot of sensitive application. So just getting back why we didn't get rid of the intent classifier for our product, that's exactly because of that reason, right? So because we know there are a lot of research going on how we can make sure LLM respect our business rule. We still haven't found any answer, so that's why we still keep the intent classifier in place, and we basically run the two in parallel. Really don't have time to cover this one, skip it. So the second one is model observability. So in the classic AI world, we did have this performance metric, like for instance, F1, precision, accuracy, things like that. And then we would collect feedback data, and we could basically trigger automated training whenever the model wasn't performing well. Whereas with the GPT model, because the model itself is black box, we don't know whether the model has been drifted or not. There was actually this article from researcher at Stanford and Berkeley University. They found that the performance of GPT-4 and GPT 3.5, they have been drifted in recent months. And that would be because there is no, again, transparency about these changes, that could be a risk for your application. So cost estimation, again, when it comes to building a ChatGPT application, you probably need to estimate how much does it cost to build an application, which is especially not trivial. If you want to do, as I said, like task alignment and setting up your vector search, there was this interesting study from Semi-Analysis that kind of estimated how much does it cost for Google if they wanted to use GPT 3.5 in their search engine, and they basically estimated, assuming Google has 320,000 queries per second, their operating income will be, there will be additional $19.5 billion to their net income, basically $36 billion reduction. So Google has a very decent argument not to integrate ChatGPT in their Google product and hosting their own model. This is an interesting kind of cheat sheet for LLM. Don't have time to cover all of it, but there's kind of like some cool practices. For instance, in regards to prompting, a lot of people have mentioned if you just add B constants to your prompt, you get much better result. Also, as I mentioned, OpenAI charge based on the length of input and output token. And when we say token is different to word, basically each word equals to 1.3, each token equals to 1.3 word. So you need to do the calculation, again, if you want to do some cost estimation for your application. And then there's this whole number for GPU memory cost that, again, if you want to host your own model, it's very important to take into account. This is just kind of best practices or most common LLM stack. If you really want to get started and build something, there are some suggestions. Don't have time to explain it, but yeah, just to sum it up, the takeaway, in context learning and small model training based on LLM are becoming more prevalent, and because of the cost, not many people are doing fine-tuning. There is a huge rise in vector databases for setting up your bring your own knowledge base. It's good to adapt some of the open source common technologies stack if you want to kind of build something and get a handoff with large language model. Again, this is kind of like my point of view. Many of the LLM applications that I have seen, they're kind of like demoware. And when it comes to scalability, again, in my opinion, they're not production ready. And as I mentioned, continuous learning, the feedback data that you collect from user is still a bit of unanswered question. Yeah, thank you.